Hi, welcome back to my channel and this is Mithuna. And today I'm going to explain about alternative methods for generating frequent item sets. And today's agenda is the appear algorithm key concepts, how the appear property use it in the algorithm, finding frequent item sets using the appear algorithm examples. The appear algorithm, what are the key concepts? You'll see key item sets, and item set having key items in it, like k is nothing but number of items. Okay, support of our frequencies, number of transactions that contain a particular item set. Frequent item set, an item set that satisfies minimum support, denoted by LK. For frequent key item sets, appear properties are all non-empty subsets of a frequent item set must be frequent. Join operations. CK. The set of candidate key item sets is generated by joining LK-1 with its L1 frequent 1 minus item sets. LK is nothing but frequent K item sets. Prune operation LK, the set of frequent K item sets is extracted from CK by pruning it, getting rid of all the non-frequent K item sets in CK. And this pruning operation is done final at C3. Iterative level vicious approach K item sets used to explore K plus 1 item sets. The appear algorithm finds the frequent K item sets. In this slide, how is the appear property used in the algorithm? Mining single dimensional Boolean association rules is a second step process. Using the appear property, find the frequent item sets. Each iteration will generate CK candidate K item sets from K C K minus 1 and LK frequent K item sets. Here CK minus 1. If suppose CK is 3, K value is 3, then CK minus 1 is 2. Okay, so use the frequent K item sets to generate association rule. Finding frequent item sets using the appear algorithm example. This is one type of example. Here you can see that the table TID and list of items. Here TID is 100 for all 100. Here number of list of items are, for first item it is I1, I2, I5. So I2, I4, I2, I3, I1, I2, I4, I1, I3. And here you can see that the n consideration of databases D consists of 9 transactions. Here number of T100 it is 9. So here it is consisting of 9 transactions. N, each transaction is represented by an item set. N suppose minimum support required is 2. 2 out of 9 is equal to 2 by 9 equal to 22%. Okay, N says minimum confidence required is 70%. So we have the first, find out the frequent item set using appear algorithm, then association rules will be generated using minimum support and minimum confidence. Here you can see that by how many times I1 I2 is repeated like this. So if number of I1 I2, in this table you can see that I1 I2 is 1, 2, 3, 4. So 4 by 9, then the percentage minimum support is being calculated and minimum confidence is 70%. Then it has been considered as minimum support K item set. And here step 1 it is generating candidate and frequent 1 item sets with minimum support equal to 2. So scan D from count of each candidate. So I1 and I2. Support count is 6, 7, 6, 2, 2. Okay, compare candidate support count with minimum support count. That is I1 equal to 6, I2 equal to 7, and I3 equal to 6, and I4 equal to 2, I5 equal to 2. So this is L1 each. So there are number of I1, I2, I3, I4, I5. how many times I1 is repeated, how many times I2 is repeated. So that number of counts it has been given here, support count. In the first iteration of the algorithm, each item is a member of the set of candidates CK along with its support count. The set of frequent one item sets L1 consists of the candidate one item set satisfying minimum support. Second step is generating candidate and frequent two item sets with minimum support is equal to 2. Generate C2 candidate generating candidate and frequent two item sets with minimum support equal to 2. And here first table table says that generating C2 candidates from L1 into L1. That means from L1 tablet to the L1. Means bit previous slide you can see that C1 to L1 it is been changed. So similar to from L1 we are generating C2. Okay, so that is I1, I2, I1, I3, I1, I4 and I1, I5. So from here I1 will be excluded. So I2, I3, I2, I4, I2, I5. Again here I2, I1 is being excluded. So I3, I4, I3, I5. And last it is I4, I5. So here scan D for count of each candidate. Here you can see that item set. The previous item set means that table before constructing C1 you see no. There if you see that number of I1, I2 that is 4 count and I1, I3 in 9 transactions I1, I3 is repeated 4 times. I1, I4 is repeated 1 time. So like this it has been checked. So next it is compare candidate support count with minimum support count. The minimum support count is 22%. So by here minimum support means that is 2. From 2 wherever that is 0 and 1 is there excluded that or neglected and remaining it has been taken as L2. That is 4, 4, 2, 4, 2, 2. Generating candidate and frequent 3 item sets with minimum support equal to 2. That is generate C3 candidate from L2. That is from L2 means L2 into L2. So we'll get here 3 item sets. Okay. So by that again same method it has been followed, and this last two steps it is it can also we can do by pruning method also. So scan D for count of each candidate. Item set is I2, I1, I3. So here the I2, I1, I3 it is repeated two times. So the C3 will be last 3 I2, I3, I4. It has been not repeated. So that reason it has been excluded. And I1, I3, I5 also it has been not there in the item set. That is 5 transaction it is there. No? So 9 transactions it is in. No? From that you can't see that I1, I3, I5. So here the final it is L3 is found out, that is compare candidate support count with minimum support count is 2 2. Okay, the generation of the set of candidate 3 item set C3 involves use of the superior property. When joint step is complete, the prune step will be used to reduce the size of C3. Prune step helps to avoid heavy computation due to large CK. Here step 4 is generating frequent 4 item set. L3 join L3, C4 is I1, I2, I3, I5. Okay. This item set is pruned since its subset is I2, I3, I5 is not frequent. Thus C4 is infinite and the algorithm terminates having found all of the frequent items. This completes our appear algorithm. What's next we'll see. These frequent item sets will be used to generate strong association rules, where strong association rule satisfies both minimum support and minimum confidence. Step 5 is generating association rules from frequent key item sets. Procedure is for each frequent item set L, generate all non-empty subsets of L. For every non-empty subset S of L, output the rule S hints to L minus S. If support count is L, then support count is S. less than or equal to minimum confidence, where minimum confidence is minimum confidence threshold 70% in our case. Back to example is, let's take L equal to I1, I2, I5. The non-empty subsets of the let's take L are I1, I2, I1, I5, I2, I5, I1, I2, I5. So here these three are the subsets, the transaction. Our final key item. Thank you.